For today's experiment, we will be doing the synthesis of salicylic acid from methyl salicylate. The point of this experiment is to determine the limiting reagent. So we will have the methyl salicylate, we will use sodium hydroxide, and we'll be using hydrochloric acid. Your job is to determine which one of these is the limiting reagent from the amounts that we use. To give you a brief rundown, what we will do real quick is we will take the methyl salicylate, we will add it to the beaker, we will add the sodium hydroxide and heat that to ensure that the reaction takes place. Then we will allow that to cool down. After cooling, we will add the hydrochloric acid. And then once we have the hydrochloric acid added, we will then do vacuum filtration, and then we will do recrystallization to ensure that we get a pure product. So the first thing we need to do is get the mass of this empty. Then we will add the methyl salicylate. We will get the mass of the beaker and the methyl salicylate, and by subtraction, we will figure out the mass of the methyl salicylate. So we are supposed to add approximately 1 milliliter. So just by getting a bowl full, that will meet our needs. Now it's time to do weights. So we've added our methyl salicylate. We'll add a glass stir rod to help prevent bumping. I'm going to add approximately 10 mils of the sodium hydroxide. And as soon as I added that, as you can see, there's a precipitate that formed. So now we will heat this, and this will actually help our reaction form the soluble salt. And we should have a clear solution. So as you can see now, we have a transparent solution. There is no more precipitate present, and the solution is boiling. So what we need to do now is allow this to cool to room temperature, and then we will add the hydrochloric acid. Okay. So we've cooled to room temperature, and now we're going to add approximately 18 mils of 4 molar hydrochloric acid. And you see a white precipitate form almost instantaneously. Now we got to mix this up. We'll stir this for about 30 seconds to a minute or so. Make sure it's all nice and mixed up. And then we need to check the pH to make sure that our solution is indeed acidic. So to do this, we will actually take the stir rod and we will touch it to the litmus paper. We do not want to stick the litmus paper into the solution itself. So at this point, it is a mixture. We do have a red litmus paper. When blue litmus paper turns red, that is an indication of an acidic solution. So we are okay to proceed to vacuum filtration. So that is this setup here. So we have a collection flask that will collect the filtrate, which essentially is what we do not want in this experiment. In order to make sure that the solid does not pass through, we have filter paper that we will put on the top. So we'll put that on, we'll turn a vacuum on. To ensure a good seal, I always kind of wet the filter paper just a little bit before I add whatever it is that I'm filtering. Go ahead and pour this in. You can see filtrate, again, which is what we are not interested in. It's being filtered to the bottom. Set aside some cold DI water that we'll use to ensure the rest of the solid material transfers to the filter. We will let air pull through there and pull the rest of the liquid through. And then when we return, we will do recrystallization. So we've let this dry on the pump for about 10 minutes now, and we're going to actually kill the vacuum. And then we're going to collect the compound that we have now and get at least a rough estimate of what the yield is that we have before we actually do a recrystallization. That's good enough. We always expect a little bit of loss during transfer. So there is still a little bit that is stuck on the filter paper and some that's actually stuck in the top of the Bachner funnel. If you take a look at this, it is a white powder is what we've collected so far. I'm going to take this to the scale and get a mass on this, and then we'll actually start the recrystallization process. So just off of a quick estimate, we have about 1 gram of crude product. What we're going to do is a recrystallization. And if you noticed, I did call this a crude product because it does have impurities in it still. And that is the purpose of the recrystallization, is to try to get rid of those impurities. So we are going to take the crude mixture and we're going to add 30 mils of water. And then we're going to heat this to a gentle boil. If there's any solid that remains, then we will add a tad bit more solvent as needed until all of our mixture has been dissolved and it's a homogeneous solution. So we're getting very close to the end of our heating process. There are still just a few particles of solid remaining. So we'll give this a couple more minutes, and then we will turn the heat off and allow the solution to cool to room temperature. At which point, we will set it off to the side, take it off the hot plate, set it off to the side, and hopefully we will actually see crystals begin to form. So a much different state for the solid than what we initially saw. So there are no solid particles left in our solution. It has been sufficiently heated, so we will go ahead and turn the heat off. We will let it sit on the hot plate for a few moments to cool down, and then we will transfer it over to our wire mesh till it cools to room temperature. Ever so closely. There are crystals beginning to form. They look like little tiny needles. We'll let this cool to the room temperature the rest of the way. We'll place it in an ice bath, and then we'll collect our crystals with vacuum filtration. Okay, so we've let this sit into an ice bath for approximately 10 to 15 minutes now, so we're going to go ahead and pull this out. Hopefully you can see maybe those are needle-like. Go ahead and turn the vacuum on. Actually. That's still the same. It's not attached. We're going to turn our vacuum on. Just a little bit. You can see they're definitely needle-like crystals. Again, we will let this sit on the vacuum and let it air dry for at least another 10 or 15 minutes. So once this is sufficiently dried on the vacuum pump, because this is water and it will take some time to dry, what we'll do is we will actually get the mass of the dried crystals, and then we will record that data, and then from that, you can actually figure out the percent yield once you figured out which one of these reagents was the limiting reagent and calculated theoretical yield.